Hello friends, welcome to the sixth video of the data science. Here in this we are going to see basic data visualization with the help of the Matplotlib. We have installed Matplotlib, but let's see how do I use this for data visualization. Matplotlib is a plotting library for Python. It is used along with NumPy to provide environment that is effective open source alternative for the MATLAB. It can be used the toolkits like PyQt, WX Python. It was created by John Hunter, and now it is under the control of Python's repository, and currently 1.9 or 1.8 is now available to work with the Matplotlib. So you can go to matplotlib.org, from where also it is downloaded. Its documentation is also available there. We have installed that by these particular methods. It's possible to install in your system. Okay, how to use? Conventionally, the package is imported into the Python script by adding the following statement. It's written here: from matplotlib import pyplot as plt, or we'll use import matplotlib.pyplot as plt. Here pyplot is the most important function in Matplotlib library, which is used to plot 2D data. Okay, one example I'll show from the three-dimensional data also. Three-dimensional data is requiring a different package where Matplotlib can't do the 3D visualization. Okay, so let's start working with this, how to perform the operation that we'll see. So in our case, I've just created some arrays here. So first of all, I'm importing the matplotlib.pyplot as plt. So plt is an alternative name provided to this particular sub package. Now four common graphs I'll show. The first graph will be the line plot, second will be scatter plot, third will be the bar plot, and the last is this histogram that we are going to see. So here I declared two arrays or two lists basically, which are of same length. I want to show their relation on the two-dimensional plane. So how to do this one? Let's see, x I have declared with some 10 elements and y with the similar number of elements, and to plot them, so I'll be using plt dot plot, this one, to print the line plot. But I require x side. So this is what my x axis is, what label I require on x side, that I will provide to x label function, and plt.y label, it's y side. And you can see a line plot will be visualized in this way. So they are incrementing accordingly. On this side we have y values which are present, and on this side x value. So first it starts from 312. So from this side we have this 3, and y side we have the 12. So in this way the plot is printed by all the default parameters present there. Now these default parameters also I can change. Let's see how to change these default parameters. So before that, let's see one more example. We want to print a sine wave. So sine wave is just, I require a sine values generated with the help of the sine formula. So here I am using arange function to create a range of element from 0 to math.py. So importing math and 0 to math.py into 2. Okay, and my increment is 0.05. So that values will be generated in the sine format. Okay, and here I am using the sine values, np.sine x, sine of x, and after that I am printing it, plotting. So when you plot that, as you can see, a sine wave can be generated from this. Similar to that, cos wave can also be possible to get generated here. Okay, so let's see few more operations to do. There is a function called as figure. So this figure function used to specify the colors or figure size also, and as well as DPI also. See, figure size means this is what we call a resolutions, 16 by 9. We might be knowing, if you are using a laptop or current televisions are also having the same resolution, 16 by 9. This is aspect ratio of your display screen. 16 is the width, 9 is the height, that we can specify here. And face color of that particular window is red, and DPI means dots per inch. So if you increment the DPI, it will become more and more clear, but it will take some time for visualization. Okay, so figure, you can see the previous output. This is how small output is this. The default resolution of it is 4:3, and see the now resolution, it is 16 by 9, where your laptop may contain the similar resolutions. Okay, that figure can do for you. Now let's see, your plot is also containing two more parameters. They are called as color and marker. The color used to specify the color of the particular line. So color is a parameter mentioned here, check it out. Color is equal to R and marker equal to star. Color, all many default colors are 16 default colors are used: red, green, blue, or if you want to use for CMYK, cyan, magenta, yellow, black, white, or pink, violet, purple. These colors are also available over here that we can use. Their single letter or complete name can be used. Or what marker are required. See the marker here, I am having a star marker written there. If I run this, so you can see the star marker. If I want a dot marker, see, so if I want a dot marker there, so this is the dot markers output. Or I require the color like pink, see the color is pink now. Or I require the gray color, this is gray. Okay, so in this way the colors can be changed. We can make use of color and marker attribute also over it to make it more interactive as per our ideas. Now instead of color, if the color is not defined, means if you the color that you are expected is not available there, so we can make use of the hash codes also. These are the HTML hash codes. You might be knowing it's a combination of red, green and blue. This is red, this is green, and this is blue. These are the hexadecimal numbers which start from 00 with the lowest value of the color and FF with the highest value of this particular color. So this is how color can also be chosen. So you can use any particular color. So for example, I want a red output maximum here, so we'll have D5 for example, max red, see, and based on that the remaining color combinations are created. Okay, one more parameter we can have, that's called as line style. See the line style created here. I'm using dot slash. So this is a line style. So when the line is drawn, this style is used over here. So such multiple styles are available. I want only dot, so dot is not available there. Okay, so the style that we can change, default style is a dash, directly dashed line will be there. This is a dotted line created by the line style. So if you require that line style, we can make use of this parameter of line style also. Now let's see, I want to draw multiple graphs on the same plane, multiple graphs. So for example, here I have declared x, y and z, all of their length is same. I want to draw x against y, x against y, and on the same plane x against z. My x is common, only the y side is changing. For first case, y side is containing the y array values, list values, and second time the y side contains z list values. Okay, so let's try that one. You can check this one. So first of all, I am plotting x against y, which is containing a red color. So red color is x against y, this one. Line style is given dash dot, and the green color is this one, which is containing a dot marker there. And their comparison, for example, if you got the data from two different years or data from two different entities which are coming under the same organizations, so we can compare them with the help of this particular graph. Whatever number of time you write the plot, all the plots will be visible on the same plane by this particular method. So we have shown two plots. Similar to that, 3, 4, 5, 6, any number of such plots are possible on the same plane. That also we can make use of. Okay, so let's see the subplot method. So this is very interesting to see here. A subplot I am using here. Subplots means in previous case I don't require all of these plots on the same plane. I require on same plane, but two different plots are required. First of all, x against y, and second x against z. See, here I am using a subplot method. Subplot method is containing three parameters. First parameter is number of rows, second parameter is number of column, and third parameter is the plot number. Okay, see the output here which is shown. I'll just focus on that. So this contains two rows. This is row number 1, this is row number 2, and column is 1. So number of rows are 2, number of column is 1, and this plot number 1, this is the plot number 1. What face color I require? Light blue is written, light blue. On that plot I have given x against y, color is equal to r, line style is dash dot. Okay, now second, 2, 1, 2. So row number 2, 2 rows, 2 columns, and plot number 2 is this. its face color is light gray, it's mentioned here, and plt dot plot x against z, which is separated here. Color is green, marker is dot. Okay, so in this way we can do. Here the most important part is to specify the row and columns position. Row and columns, how many rows and columns you require, and what plot number will be having over there. So that's our required here. Let's see, I have created one more plot over here. So for first case I'm using row number 2, column number 1, and plot number 1. This is row number, number of rows are 2, we are having this 2. Now this is first plot, okay, 2 1 1, which is generated here with x against y, and r is the red color, line style is this. Now if subplot 2 2 1, 2 by 2 is 2 rows and 2 columns. If you create 2 rows and 2 columns there, this plot will be the first plot, this is the second plot, okay, 2 parts will be there, this is third plot. So I require this plot at third position here, and one more plot z against y as the fourth position here. See this one. So as per our requirement, you can adjust it at this particular position there by number of rows and number of columns, and print or show or visualize these graphs accordingly in this way. Okay, so subplot is very useful function to separate the graphs. Now let's have few more properties that I can apply here. Here two functions I have used. They are called as lim, x lim, y lim. So according to the limits, according to the values, according to the range values specified there, we can specify the limits from which minimum value of x will start and which is maximum value of x will be there. So I have specified limits. It means that the x side will start from 0 till 125 and y side will start from 0 till 125. See here, okay, you have specified these limits, and accordingly that they are changing here. Okay, if I'm incrementing the limits here, so let's have 150 here, also 150, and see the output. See, so start from 0 to 150, here also 0 to 150, and based on that the plot is created here. So this is x limit and y limit. Based on it we can change your limits, and accordingly the graph visualization will get changed. Okay, we can add the ticks also. So let's add the ticks. Ticks means, see, you can check this out. Here I am having a ticks from 20 ranges, default 0 to 20 to 40 to 60 to 80 to 100, 120 and 140. I don't require that. I want these ticks to be in the 10th range. So let's see, I'm giving the x ticks here. On x side the ticks will start from 0 to 125, increment by 10. 0 to 125 increment by 10. So you start from 0, then 10, 20, 30, 40, 50, 60, 70, 80, like all, it will go till 125, increment by 10. Okay, and for this side also we are having the same method, 0 to 125, increment by 10. Okay, so every ticks is containing 10 elements over there. And even if I want to draw a grid over it, that is also possible. So you can have a grid. So let's try plt dot grid. So you can have a grid over it. See, the grid can be seen, and usually we can match the values of x and y with the help of this particular grid here. That's how it's possible to add the grids. There is one more way by which we can add the labels to this also. Labels, it means, see how to add the labels. Where the multiple plots are there, their labels are so much useful. Okay, so labels means, see, what this name specifies means I'll have the label. For example, this data is of 2019 and this data belongs to 2020. Okay, that's one label I have given, and then I'll let plt dot legend. So legend is the informative window shown on the plane to specify which graph belongs to which particular entity. Okay, let's see this. Okay, this is what the legend means, and the labels are required as specified here. Means red one is 2019 and the green one is 2020. So in this way I can specify it, and then the graph will be visualized accordingly. Okay, this is what the labels are, limits that we have seen. Then x ticks. Okay, fine. Now let's come with the second kind of the plots called as a scatter plot. Scatter plot is similar to the line plot, but they are represented by the dot. See this plt dot label, x label, y label are given, and then plt dot scatter x, y. So where x and y are matching, there we can have the dot represented there. See this dot represented. So the dotted plot will be created, and all other properties that we have seen for the line plots will be same here also. Only the difference is that the plot is represented by the dot in scatter, and the plot is represented by the line in the basic plot, line plot there. See, for example, I want to change the color. Color is equal to green. Okay, see, this is how we can add these properties here. Or I want to add the marker, add simple dot marker. See, this is the O marker, default is O marker, and I have changed it to the dot marker. So these properties, whatever properties that line plot contains, they are applicable as it is here also, like x limit, y limit, x ticks, y ticks, figure, all they are possible as it is here in this particular scatter plot also. Now I want to represent this scatter plot in the third dimension 3D format. See how to use 3D format, it's very useful there. I'm using the package called as mpl_toolkits. See, mpl_toolkits, import mplot3d. So mplot3d function used to plot the data, or the I want to visualize it in the form of a 3-dimension format. Now how to do this one? First of all, I am creating a figure, plt.figure here, fig, then plt.axis projection. I am going to use 3D with ax, and now here I have created linearly spaced 100 elements. Okay, so 0 to 1, that is what z is created here. It's not required actually. We'll delete this. Okay, x, y, z. So these 3 axes I have created, and now ax, which is axis, dot plot 3d x comma y comma z, and then I have given the color of it. Now let's see how the 3D plot is visualized, x, y, and z. Okay, and then I have given the title also, set title. So same I can use with the plot, plt dot title is also similar to that. We can have this title given there, and see how the plot is visualized. Okay, so same I can, this is line graphs, I can use the scatter plot also. Check out the scatter plot. So here what I have done, here scatter function I am using, remaining other operations are almost same. Scatter operation I am using, and I'll change the color according to addition of x and y. So different values of color is given to every dot. That parameter is c here. So c is a special parameter to the scatter function, where the color of individual dot can be changed by this particular method. So everyone contain different color. It creates a number here by x and y's addition, and accordingly that the colors are different for the dots presented on this 3D scatter plot. Okay, now before actually going to the next program, I'll just show a simple example. I want to save this particular plot in your system. So to do this one, 2 things are there here: import pylab, and then pylab.savefig. So basically figure which is printed in between, see, plt.plot and x comma y. Okay, so this plot is generated here. Many properties also we can apply and make use of them, but this plot is also saved in your current working directory with the name main.png. So let's go to current working directory. This is my current working directory, and main.png is generated here. Yes, this is, see, I just open that main.png. All other applications, like we can change the resolution of it, we can add the colors, we can add the markers, or we can add some extra properties like legends, ticks, grid. Everything is possible, and we can add it, and then accordingly the graph can be seen over here. Okay, so import the pylab, and pylab.savefig will save the figure which is just printed above. Okay, that's how we can make use of. This is applicable to all kind of the graphs that we use from the Matplotlib, or any other kind of package like Seaborn is also there. There also we can make use of it. Now let's go for the third kind of the plot, that's called as a bar plot. So here I'm creating 2 bar plots on the same plane. I'm using x 5, 8 and 10, and y is equal to 12, 16 and 6, and x2 6, 9 and 11, and y2 is 6, 15 and 7. Now let's see bar. This function, bar function, is to create the bar plot. X against y, alignment is center, and here x2 against y2. color is green, alignment is center. Then I've given the title. This title is to show the title. See this title applicable to scatter plot also, and the previous two plots also we can make use of the title. Then X label, Y label, and when you run this, we can create the bars like this, again X against Y. Okay, check this X axis, and on Y axis how the values are represented, that we can see. So most of the time bar graph doesn't require both the parameters. If you are given a single parameter, then also the bar plot as per the variation changes will be shown over there on X axis. Okay, this is how the bar plot can be generated. Just can try on your system also. And the last plot is the histogram. We have seen the histogram in pandas also. There also it is useful, and for using the histogram here in the Matplotlib is also beneficial. So you can use, for example, histogram. We know that it's a frequency plot. What's the frequency of elements that particular range contain, that we can find by using the histogram. So some values are created here in array format. Not required, that should be in array format. We can have list format also, we can have series format also, anything is possible. And then plt.hist. So hist is a function to show the histogram. This a will be given as first parameter. Bins contain the ranges. Ranges means 0 to 25 to 50 to 75 to 100. So 0 to here 25, how many elements are there? Then till 50, how many elements are there? So here till 50, and 50 to 75, 75 to 100. 75 to 100, 2 elements are there. 50 to 75, 5 elements are there. In this range we have 25 to 53 elements. Here we have 5 elements. So frequency of elements within a specific range can be found with the help of these histogram functions. So these are the commonly used 4 different kind of the graphs will be requiring in data science applications. Maybe I'll show the applications of them when the algorithms are coming. So in a specific algorithm, when you learn, I will show where we can apply this. The line plot, the first plot, is very beneficial in many cases. Even scatter plot also, in many cases we are using that in regression algorithms, in classification algorithms also. I'll show their application that time. Till then, practice all, and thank you.